As you're filing in and finding a seat, I want to welcome you to Science Unwrapped. And this is our second presentation in our Celebrate Undergraduate Research theme for this year, which is the year of undergrad research at Utah State University. I'm Dennis Newell. I am the interim department head in the Department of Geosciences here at Utah State. And I am standing in for Brynja Kohler, who's normally hosting these events. Show of hands, how many of you have been to a Science Unwrapped in the past? Oh, okay, I can leave. You all know what's going to happen next. But for those of you who are new, the way this is going to work is our speaker here is going to give about a 2-hour talk.
Sorry.
No, he's going to talk for 40 minutes, right?
We'll shoot for that.
And then after that, there'll be some time for questions. But there'll be a short pause between Josh's talk and when we do question and answer to have folks who would like to file out and join our volunteer activities and refreshments. So you don't need to stay for those question and answer if you don't want to, and you can file on out. But that's how we'll do that. And I'd like to highlight that this evening we have 20 volunteers and activity tables out there for you tonight. So that's a big number, and that includes 3 new groups that I'd like to highlight. There's the Robinson Lab from the USU Department of Biology, the USU chapter of Tau Beta Pi, the Engineering Society, Honor Society, along with USU's chapter of Operation Smile. So we also, because it is the year of undergrad research, have a number of undergraduate researchers who have their posters out in the lobby out here for you to visit and ask them questions. So please interact with our undergraduate researchers. Okay, well, I'd like to welcome, and we're very excited to have Dr. Josh Lively here. He's the curator of paleontology at the Prehistoric Museum at Utah State University in Eastern. So Josh has come up here from Price, which is about 200 miles away. Fortunately, the winter weather wasn't too bad for you, but he's spending a few days here at Utah State doing this talk tonight, and then he's going to join us tomorrow for Rock and Fossil Day, which you're all invited to, which is over in the geology department. It's open to the public. So we hope to see you tomorrow, Saturday, from 10 to 3 o'clock for Rock and Fossil Day. Admission is free to that event. So about Josh, he's a native of Alabama. He did his bachelor's in geology at Auburn, and then he came out west and did a master's degree at the University of Utah. And we're not going to hold that against him, are we? No, we're not. And then he did his doctorate work at UT Austin, and then he joined us at USU Eastern in 2020. Dr. Lively he's a paleontologist, and his research focuses on ancient freshwater turtles and giant marine lizards, mosasaurs.
That's right.
But that's not what you're talking about tonight, necessarily.
A little bit of that, but not much.
Okay, and he's going to talk to us tonight about interesting discoveries that you can find here in Utah. So let's all welcome Dr. Josh Lively for his talk tonight.
Thank you so much for having me. I can hear myself, so that means y'all can probably hear me too. Thank you for that introduction, and thank all of you for coming to the talk. Thanks for the College of Science for having me up from USU Eastern and Price. So yeah, it's interesting. Usually when graduate students transition to faculty positions, they kind of have a narrow research area. I study this one thing. For paleontologists, it might be I study this one group of critters. I got this job back in 2020 down in Price at the Prehistoric Museum, and the mandate, the goal of this museum, the mission, is to tell the story of life in eastern Utah. That's a broad goal. So, where some people narrow, I got my job and it kind of did this. So what I'm going to do, I'm going to use our museum's field program, current and past, at least little snippets of it, to kind of tell you the story of the history of life that is recorded right here in the rocks in Utah, with kind of a focus on the Age of Dinosaurs, because, hey, that's what we like. And it's actually one of our strengths. So just to fill you in a little bit on the Prehistoric Museum, how many of you have been to Price, Utah? Okay, a few of you. Quick calculation, maybe like a little bit over 50%. How many of you have been to the Prehistoric Museum? Okay, fewer people. So goal number one, it's not me. Goal number one, next time you drive through Price, Utah, definitely stop by and see us at the Prehistoric Museum. We're open 7 days a week, but it's a really good spot. It's kind of, if you're heading down to Moab, it's right there on the way, about 2 hours away from Moab. And this museum is actually one of the oldest natural history museums in the state. It's actually older than the Natural History Museum of Utah. I think the Fieldhouse Museum in Vernal is the oldest. But this museum was founded in 1961. And it was founded by a faculty member then it was called Carbon College. Then it became the College of Eastern Utah. Now it's USU Eastern. Founder's name was Don Burge. And him and his friends around Carbon County, Emery County, that part of eastern Utah, they all got together and they said, we've got a lot of stuff. We've got a lot of fossils. We've got a lot of artifacts in this area. We should have a museum. So Don Burge really got together with members of the community and as a community effort founded this museum, the Prehistoric Museum. This is what it looks like. This is Don up here on the screen holding hands with one of his babies in the museum there. And then this is a look at the museum. Started out upstairs in one of the city buildings, moved to the city gymnasium, and then eventually was expanded later on. This is a look at one of the first mounted dinosaurs that went into the museum. I'll give you a hint as to what this animal is. It's Utah's state fossil. Who knows what that is? Just shout it out. Allosaurus. Yeah, that's right. So Allosaurus is Utah's state fossil. I think it's been our state fossil since 1988. We just recently also got a state dinosaur. So our state fossil is a dinosaur. We have a state dinosaur that's a different dinosaur. It can get confusing. But Allosaurus was kind of one of the first attractions at our museum. So this is what the museum looks like today. We've got a bronze Utah raptor outside. We've got a new affiliation now compared to when it was founded with Utah State. So as I mentioned, we're open 7 days a week. And what's really neat, we're also one of the few accredited museums in the state of Utah. The state of Utah is really unique in that we have somewhere over 250 museums in this state. There are more museums than there are McDonald's and maybe Walmart's combined, like by a long shot. So it's kind of a neat place. Most of those, of course, are history and cultural, but we have quite a few natural history museums as well. And very few of those museums, I think 6 of us-ish, are accredited by the American Alliance of Museums. That's basically meaning that you meet all of the top standards for museums. The Prehistoric Museum, we are one of those 6. The Art Museum here on this campus is one of the other, and then all the rest are on the Wasatch Front. So we have one here in Cache Valley. Ours is the only one in really, truly rural Utah because all the rest are around Salt Lake and Provo. And hey, if you want to stay up to date with what we do, our field work, all that good stuff, you can find us on Facebook, Instagram, and Blue Sky. You can take a snapshot of that if you want to follow our socials. So now I want to take you through time and really highlight a lot of the work that we do just through the different snapshots in time. In the rocks of eastern Utah. What's really neat, when you have a mission to tell the story of life in eastern Utah, we're actually able to do that. Very few places on the planet can you go through basically the entire geologic time scale without leaving the state. And the state of Utah is one of the places that you can do that. So one of the first rock units that I want to talk about is from the earliest stages of the Age of Dinosaurs, the Triassic period. And these rocks are called the Chinle Formation. Our project in these rocks is in Emery County, right kind of in the center of the state. Before I started, there hadn't been a lot of exploration in this part of this rock unit in Emery County in the San Rafael Swell. It's a big recreation area. A lot of people go there for ATVs, riding ATVs, hiking, biking, all that sort of thing. But there are fossils in these hills. So we wanted to go out and find them. And sure enough, we have found a few fossils out here, mostly footprint. Track sites, but then a few rare body fossils, some bones as well. These are what the rocks look like. If you hike out through these rocks, you will come back with your boots stained red. This is definitely red rock country in these parts. Beautiful landscapes. And then sometimes you find little outcrops like this. When we're out looking for fossils, step one is to find the right aged rocks. Step two, the right type of rocks that preserve what you want to find. You're going to see some examples today. And then step three, hike around and stare at the ground. It's as simple as that. If you like to hike and you don't mind being outside, and you like cool dead things, you too can find fossils. This site right here in particular is kind of caught our eye because there was a lot of flat rock. And what we found was actually a lot of tracks. I don't have time to show you all of them, but something that we found here, I'll toggle back and forth. This one particular footprint that is 1, 2, 3, 4, 5 toes, just like us. This is from an animal called a phytosaur. So that skeleton on the screen right there is a phytosaur. If you met this in a dark alley, you might say that's a crocodile. It's actually not. These animals looked like crocodiles before crocodiles were doing crocodile-like things. So they were swimming around in the rivers and the lakes during the early stages of the Age of Dinosaurs. And they are some of the most common fossils that we find in these rocks. There's a limb bone. This is the shin, so the tibia, the bone between your knee and your ankle. Phytosaurs have the same bone, and that's one that we found out in the field. So lots and lots of phytosaurs. We have the potential to find early dinosaurs in this formation, which is our big goal. I mean, we broadly are interested in the entire ecosystem, all the animals, all the plants, but, we kind of want to find early dinosaurs. There's only been one or a couple of early dinosaur fossils found in Utah, so any that we find would be really great. But the landscapes are really beautiful. The rocks, in some cases, are very hard. So this is my colleague, Natalie. She's a paleontologist over in Colorado. She's running a concrete saw there to try to get, believe it or not, a phytosaur out of the rock. And this is because our rock hammers and chisels and everything are not good enough to get through this rock. It's way too hard. So we'll use concrete saws, sometimes jackhammers out in the field to get these critters out of the ground. We're going to fast forward in time to a word that you've probably heard before, the Jurassic. They made a few movies with this in the title. This is kind of the heyday of the Age of Dinosaurs. And in particular, there are some rocks in Utah and all across the Intermountain West called the Morrison Formation that preserve a lot of different types of dinosaurs. And one of these sites that's really important to our museum's history, but the history of paleontology in the state of Utah, is at what's now Jurassic National Monument, also known as the Cleveland Lloyd Dinosaur Quarry. And this is a famous site because it's the world's largest concentration of predatory dinosaurs anywhere. And it just so happens it's our state fossil, Allosaurus. It's probably why we have Allosaurus as our state fossil, because you find more of them in this one hole in the ground in Emery County than anywhere else in the world. But we've also got quite a few other localities from around Jurassic National Monument, including one of my favorite fossils in our museum, which I'll talk about in a couple slides. So here's our Allosaurus. This is usually referred to as Big Al in our museum. It's an Allosaurus kind of pieced together from fossils from Cleveland Lloyd Dinosaur Quarry. And you can't really see it in the background here. We also have a Stegosaurus on exhibit. Stegosaurus was living at the same time as Allosaurus. We have direct evidence they interacted with one another. And then also quite a few other dinosaurs, your long-necked sauropods, plenty of those living at the same time. But what's really neat about the Cleveland Lloyd Dinosaur Quarry, our museum worked there a little bit in the 90s. It's mostly been excavated by the University of Utah and other institutions. With the largest concentration of Allosaurus, they actually get a full range of sizes. So I'm going to have these two bones at Rock and Fossil Day tomorrow. But the big one, the big toothy one, is basically a subadult teenage Allosaurus. It's about yay big, about foot and a half long. That little bone that's kind of up on the block of foam that's a little bit smaller, that is the same exact bone from a smaller Allosaurus. So we get everything from babies all the way up to adults in this one hole in the ground. So people actually come from all over the world to study Allosaurus here in Utah because you've got a really great sample of their bones from one site. So we know it's one population, probably all living together at the same time, babies all the way up to adults. So it's a really great opportunity to study these animals. But, we've got all sorts of dinosaurs, big, small, everything in between. But one of my favorite fossils is still undescribed from the Morrison. This is a tiny little croc that we have. I call it our Chihuahua croc. Full grown, it's about the size of a Chihuahua. So this is an adult animal. Those are some, at the top of the screen, those are some pieces of armor from the back of this little tiny crocodile. That image on the right, in between the tweezers, that's an ankle bone. So, you think about our heel. Our heel is about yay big-ish. We're going to say the size of a pear because I don't know why. This thing fits between two little tweezers. That's the same bone. So this is a really, really tiny croc, and it's an adult. And we know based on the shape of the limbs, it's not swimming around, sprawled out on all fours. It's got its legs up underneath the body. It's running around on land. So this is a really neat croc. This one particular group of crocs is mostly known from Europe. Only one little section of jaw has been found from North America, so this is probably a brand new species. Still a lot of work to do on this, though. So that's the Jurassic. I kind of blow through that because a lot of folks have worked in the Jurassic in the western U.S. over the years, and we've learned a lot about it. There's a lot of other time periods that we don't know as much about, and places like eastern Utah are really the place to go to learn about that. So there's one particular site that my museum worked in the late 80s and early 90s called the Gaston Quarry. It's in this rock unit called the Cedar Mountain Formation, and it's about 135 million years old. So just into the Cretaceous time period from the Jurassic. And this site is really important. It's what we call a bone bed. So that means there are multiple individual animals being preserved at this one site. Most famous for two particular animals, Gastonia and Utahraptor, which is now our state dinosaur. This is the guy who found the site, Rob Gaston, excavating there. Just about every block of, this is a historic photo, well, historic. It's only the early 90s. We can't call that historic yet. But it's an older photo, so it's not the highest quality. But basically everything that you see in that screen is a bone, is a dinosaur bone. Mostly from this animal right here called Gastonia. This is an ankylosaur or an armored dinosaur. Turns out we have tons and tons of ankylosaur fossils right here in Utah. And this is the skull that came out of that site. You can see this on display in our museum. We don't keep this behind lock and key. We have it on display in our exhibit hall. And it's one of the nicer ankylosaur skulls from this early member of the group. And so they were excavating the site. They knew they had a lot of these armored dinosaurs. And they were digging for a couple of years. And one of the volunteers at the site called the paleontologist over and said, "Hey, I've got this weird looking rib." The paleontologist looked at it and said, "Well, that's no rib. That's a big claw." And so they found more of the animal. It turned out it was a brand new species. It was a raptor dinosaur, a dromaeosaur. But what was really neat is that it was the largest dromaeosaur that had been known. And it's still the largest raptor dinosaur on the planet. Most raptors have a claw that's about yay big. This claw is about 2 or 3 times bigger than that. So this was discovered in 1991 by one of the museum's volunteers. Does anyone know, paleontology-wise, pop culture, what happened in 1993? All right, somebody said it, Jurassic Park. So Jurassic Park came out in 93, the same year that Utah Raptor was named. So if you watch the movie, if you watch Jurassic Park, you see these big velociraptors in the movie. If a velociraptor was up here in the front with me, it'd be about yay big, about the size of a turkey. Now, you still probably wouldn't want to mess with a turkey-sized raptor. It would be feisty, I bet. But Utah Raptor was actually even bigger than the raptors in the movies. We're talking about a raptor maybe between black bear and grizzly bear size if it's standing on its hind limbs. So this is something that, you would not want to meet in the wild. So our fossil at the Prehistoric Museum was the first Utah raptor ever discovered. And so anyone on the planet who wants to study raptor dinosaurs has to come to Price, Utah to look at Utah raptor. So since then, other Utah raptor fossils have been found, but ours was the first. This is our founder, Don Burge, and his preparator, John Bird, mounting the first reconstructed skeleton of Utah raptor back in the early 90s at our museum. So fast forward a little bit, just barely in geologic time, only about 3 million years later, and we've got another site in the Cedar Mountain Formation. This was discovered by someone named Lori McWhinney, who was a volunteer at the Denver Museum. So this is called Lori's site. It's about 132 million years old, and this is another site with a dinosaur very similar to our Gastonia. So lots and lots of armored dinosaurs at this site as well. The difference is this is a much bigger site. The Gaston Quarry, that first Gastonia site, would fit on most of this stage here in front. This bone bed of many, many individuals covers about 2 acres of land. And anywhere that you dig in within that bone bed, you hit fossils. It's the largest concentration of armored dinosaurs in the world and one of the biggest bone beds. So there's Margie, one of my volunteers. We reopened this site. It was worked in the 90s and early 2000s. We reopened this site in 2023 because the Denver Museum that had previously dug there wasn't as interested anymore in working it. So we put shovel in ground that fall. And when we got down to the bone layer, I had heard these stories about how dense the bones were in this quarry. It turns out they were right. Every yellow arrow on the screen is pointing to a different bone, and there are a lot of smaller bones in between there too. So you can't dig in this quarry without hitting bone. It actually makes it really hard to dig up the fossils because normally we try to dig around bones when we're excavating them, but every time you try to do that at this site, you hit another bone. It's a challenge. In a lot of sites, the bone and the rock around it are kind of easy to distinguish. That's hard in some of the places here. So I'll highlight these 2 bones. These are 2 different pieces of armor from this ankylosaur. So the one on the left is a plate from the side of the tail. The one on the right we thought was another plate. It turned out to be a dorsal spine. So these are those same bones prepped out once we get it back to the museum. And so that big spike or spine on the right would have been sitting on top of the animal. The plate on the left would be coming out the sides of the tail. And I'm going to show you this just to kind of show you the technological advances that we can do even while we're digging up fossils today. This is a three-dimensional scan of this dig site, kind of showing you just how many bones are in this locality. This is a LiDAR scan that I did with my iPhone. So you don't need huge technology for it. But we're looking at a thigh bone there of one of these armored dinosaurs, zooming in on another armor plate. Again, this isn't a video. This is a 3D scan of the bone bed, just to show you just how many bones are at this site. It's kind of ridiculous. This is zooming in now on one of the shoulder blades. That little curved out area is the socket where the upper arm bone, the humerus, fits into the shoulder. So that's just a little brief tour of a small section of this 2-acre bone bed. It's a really, really neat site. So lots and lots of ankylosaur bones. But while we were digging this site in 2023, one of my volunteers, Heather, found this bone. This is a very slender bone, kind of right there in the center of that rock that I'm holding. This is a bone called a metacarpal, is basically the fancy word for hand bone. This is from a raptor dinosaur. So we don't know if it's something similar to Utah raptor, or if it's, if it is, it would be a baby. It would be a juvenile. Or if it's just a smaller species of raptor. That's all we've found so far. We also found this. This was also another discovery by that volunteer, Heather. This is, she handed this to me, and I said, that looks like a tooth. In the center of that circle, there's a little tooth. And zooming in on it, I realized this is an armored dinosaur tooth. This is an ankylosaur tooth, and there's actually a little piece of jaw that it attaches to. It was in a bunch of fragments that were all kind of associated together. And I said, I think that's really small for an ankylosaur tooth. Showed it to Jim Kirkland, our state paleontologist who was on the dig, and he said that's the smallest ankylosaur tooth I've ever seen, and he's seen most of them on the planet. So this is what that looks like put back together, my wrinkly hand for scale. And it turns out this is the front of the lower jaw, as far as I can tell so far. And sure enough, this is a baby. At least a very, very small individual. I'm still collecting some data on just how small it possibly is. But one thing I'm doing there, one thing I'm up to while I'm in town is working actually right through this door in a lab next to this room. It's a micro CT scanner that's right here, managed by the biology department. And so I took these scans yesterday. I was able to put them into my talk. These are some CT scans of that baby ankylosaur. So I can see the teeth. We can see the, even like the texture of the bone. This is a really good scanner. I did not know how good the micro CT scanner was until I came here and saw these data today, and it's phenomenal. So thanks to the staff, Lauren and Dr. Al Savitsky here at the biology department, who have let me come in and work in this facility. Some really, really great stuff out of this. What's really neat about this, about having a juvenile dinosaur, or a juvenile ankylosaur at this site, is that normally ankylosaurs are just found in groups of adults, or in a few places in Asia as groups of juveniles. So the idea was that babies, the eggs were laid, they hatch, maybe stuck together as best they could, but they were doing their own thing. This is the first co-occurrence of babies all the way up to adults at one locality for a group of ankylosaurs. So potentially a really big discovery. And back in 2023, when we were excavating this site, another very exciting thing is that we were being filmed. So there's a reboot of a 1999 series called Walking with Dinosaurs with the BBC and PBS that'll be coming out this summer. So we are one of the 6 episodes. They filmed in Africa, Europe, Canada, Montana, and then Eastern Utah with us. So it should come out on PBS maybe sometime in June. So watch for us there. So more armored dinosaurs. Yeah, we're getting a little bit forward in time. This rock formation called the Cedar Mountain Formation really captures a period of time between the Jurassic and the late Cretaceous. Really famous time periods for dinosaurs. Stegosaurus, T-Rex later on. So we have good understanding of those time periods, but it was that in-between time in the early Cretaceous that we didn't really understand or didn't start understanding until about 30 years ago. And it's these these localities in this rock formation across eastern and central Utah that have really helped tell this story. So we've got this one site just outside of Wellington, Utah, about 15 miles from our museum, called the Price River 2 Quarry. 2 brand new species of ankylosaurs were named from there in the late 90s. And then we even have this massive collection of long-necked dinosaurs, sauropods, from this site as well. Turns out one of these dinosaurs, Paleontology, is more famous than you might think. We're the only museum on the planet that has its fossils. There have only been a couple of individuals found at this one locality. And so we have all the fossils of this animal. But I was rewatching one of the Jurassic World movies after I got this job. And it's a Jurassic World Fallen Kingdom. It's kind of dark on the screen up there. It's basically this rich dude in the movie has a mansion and a museum in his mansion. And one of the mounted skeletons there is Paleontology from, right in our neck of the woods. So I said, hey, there's our dinosaur. It would have been nice to have a label on it and say Prehistoric Museum, USU Eastern. They didn't, but, we at least made it into the movie. So we've got a couple of armored dinosaurs there, but the big thing are these sauropods. So this right here that I've got with me is a cast of one of the bones from that locality. So sauropods are your long-necked dinosaurs. Think Brontosaurus, Brachiosaurus, all of those, Diplodocus. This is probably an animal called Sauroposeidon. For years, folks haven't really studied these fossils yet. We have over 1,100 bones from this one locality. And at least 11 individuals of this sauropod. Just to give you an idea of what this bone is. So this is a femur. This is a thigh bone. If you don't know where your thigh bone is, you can put one finger on your knee, another finger on your hip. That bone in between is your femur. So this one is a little bit bigger than mine. And this one isn't even the biggest one we have. We have one that's a little bit over 6 feet tall. So we're talking about massive, massive animals. And we have multiple of them from this site. So one thing that's a big challenge when you have bones that are this big is that if you put them on a shelf in your collection space, they'll crumble under their own weight. So you have to be able to support them somehow. And this is where you start hiring undergrads to help with your research projects. So we got a grant from the Bureau of Land Management a few years ago that funded us to build these cradles for these big giant sauropod bones. So all of these bones on the screen are sitting in plaster and fiberglass cradles that our lab staff, including volunteers as well as student interns from USU, they helped us build all of these to help protect these fossils. So, that means you have to have a really big sandbox to be able to build these. So we actually worked with our welding department on the USU Eastern campus to build a big metal sandbox that's 8 feet long by 4 feet wide to be able to fit all of these bones. So a bone like this needs a big cradle, so you need a lot of space to be able to do that. So that's one example of both community as well as student involvement in our research. And we're about to see a lot more. So now we're getting into one of my time periods where I'm really comfortable. This is in the marine environment, so under the water, under the sea, during the Age of Dinosaurs. And this is a rock unit called the Tropic Shale down in Grand Staircase Escalante National Monument. These rocks are about 94 million years old, so we're going further forward in time through the Age of Dinosaurs. We're, like I said, mostly working in the National Monument. We've found a lot of marine fossils down there just working there over the last few years. These really big fish called Xiphactinus. We find marine reptiles, including plesiosaurs, and then also one of the oldest mosasaurs on the planet. So here's some examples of different fossils that we find in the Tropic Shale. The one on the left is the bottom part of the shell of a sea turtle, or at least a portion of it. The one on the right is actually, believe it or not, a shark tooth. Doesn't look right for a shark tooth. Normally when we think about sharks, we think about little pointy teeth. This is a big round tooth. And that's because this shark was eating something different. What do sharks normally eat? Fish, slippery stuff, you're a very unlucky person if they're swimming in the wrong water and look like a seal. So they've got sharp teeth to deal with meat. If you've got a big round tooth, can you pierce a fish? No. So what do you think it's eating with that? Heard somebody say it, shells. So yeah, these sharks, they're sharks. We know what they look like because we find their skeletons. One was discovered just last year and described. So it's a shark. We know that for sure. But it's a shark that eats clams and oysters and other hard-shelled animals. So it was a weird time. We had some of the same types of animals that we have in the ocean today. Sea turtles, fish, sharks. Some of them were doing slightly different things though. On one of our spring break expeditions a couple of years ago, we found a plesiosaur, which is the animal up there at the top of the screen. Big flippers, kind of a long snout, short tail. This animal, plesiosaurs aren't related to any groups of modern reptiles. They did their own thing during the Age of Dinosaurs and then died out. So these animals would have been swimming with their flippers, moving their paddles through the ocean. And you can see here on the right-hand side of the screen, those are some parts of the backbone, parts of the spine from this plesiosaur. And then we've got a couple of USU students there, Whitney and Michaela in the middle, mapping out those bones where they are in the quarry to try to help us figure out how they're oriented and help us understand how that animal was preserved. So we spent about a week digging parts of this animal up. There's me hammering out a field jacket. Plaster and burlap protects our fossils when we bring them back to the museum. And then a group of our field crew on the right carrying one of the bigger fossils out of the back country back to the road on a stretcher board. Then we have what I think is one of the more interesting animals. It's very small, but this was a fossil that was discovered by one of our volunteers named Justin McKee. He was an undergrad at the time, and he's now doing a master's in paleontology up at the University of Alberta. This was our first field season out in the Tropic Shale. You learn when you get into paleontology, it's kind of like fishing. Sometimes you're lucky, sometimes you're not. I'm not very lucky when it comes to finding fossils. My volunteers are really good, though, so I rely on them to find most of our fossils. So I had hiked for 10 miles that day. I saw one shark tooth. I was kind of, bummed out. Get back to camp, and Justin hands me this fossil and says, "What's this?" I said, "That's a mosasaur." Kind of pulls at my heartstrings because that's what I did my PhD project on. The cool thing is, there aren't many mosasaurs that are this old. Most mosasaurs you get about 10 million years later in time. So this is a very early mosasaur. And in fact, 2 years ago, a mosasaur was named from the tropic shale called Sarabasaurus, which means mirage lizard, because if you hike through these rocks enough, you'll start seeing things. But that's what this animal would have looked like. Basically, like a lizard that you threw into the ocean, essentially. So we've since found more parts of this, and I even CT scanned parts of the skull on this trip. So cool new discoveries there. So now we're going to go a little bit further into time, forward into time, later into the Cretaceous to rocks that are about 75 million years old. And we're going to go out of southern Utah back up to kind of central eastern Utah in the Book Cliffs. How many of you have driven over across I-70 towards Colorado? Show of hands. A few of y'all. All right. Well, if and when you do, if you drive towards Grand Junction, you'll go down Highway 6 past Price. You'll stop and see us at the Prehistoric Museum. And then you'll go down and hit I-70 and then go east to Colorado. You're driving along the Book Cliffs, which is the longest continuous cliff face in the world. And there are a lot of really interesting rocks there that hadn't been explored for fossils until just a few years ago when we started. So this particular formation that's kind of towards the end of the Age of Dinosaurs, we only have about 9 or 10 million years left at this point, had largely been unexplored. So we didn't know if we would find anything. We said the rocks are the right type of rocks. They're the right age rocks. Let's go look for fossils. And we actually did find some fossils. This was a really interesting rock unit for me because all up and down western North America, you get rocks of this same age from Mexico all the way up into Alberta. Now, why is that interesting for a paleontologist? Normally, we're looking at just little snapshots in time, snapshots in geography. This is a time period where we have so many of the same aged rocks preserved and fossils in those rocks that you can start asking biological, ecosystem type questions. How are these animals changing across the landscape? And this formation, the Neslin Formation in the Book Cliffs, is kind of right in the middle of some better studied stuff to the south and to the north. So at that time, North America looked very different. You had this shallow sea connecting the Arctic to the Gulf of Mexico. And so you could not walk from Western North America to Eastern North America. In a very narrow area between the mountains and that shallow sea. But lots of different animals. And the animals are changing as you move from south to north. So the Neslin Formation might inform us a little bit on this pattern. Previous discoveries from this formation before we started, basically 2 fossils, part of a tyrannosaur foot, not enough to name, and then this duck-billed dinosaur at BYU called Rhinorex. Both of these found by geologists, not out there looking for fossils. They were looking at the rocks. So that's why I said there really ought to be more fossils out there. This is what the landscape looks like. Some of it is super cliffy. It's called the Book Cliffs for a reason. It is very cliffy out there. And you zoom in on these rocks, and this is what they look like. They're really dark. And when you have dark mudstones that look like this, that even kind of grade into coal seams, that's telling you that you've got this swampy environment, which is what we would expect on the edge of a seaway. Central Utah would have looked like Louisiana 75 million years ago. So a very different environment, very wet, very humid, very swampy, lots of plants, and then big critters walking through those swamps. So we've done a lot of work on the Neslin now. We've collected hundreds of fossils from the formation. And this has been a really good opportunity to get students and other volunteers involved in the research. So Whitney Greaves right here in the lower right is a recent graduate of USU Geology. She's actually going to have her research poster outside after the presentation. So you can go talk to Whitney about all of her research on the plants from this formation. plant fossils are really important because they tell you about the environment. You might have a dinosaur, that doesn't really tell you anything other than, oh, there was a big critter living here. But the plants really tell you about what the environment was like. And we've found tons of plants. One of the cool things, we have a new species of conifer cone, so something like a pine tree. This is something that Whitney discovered through her undergraduate research with us right here at USU. Lots of flowering plants, lots of these things called monkey puzzle or Norfolk Island pines that are only found in the southern hemisphere today, but were growing in eastern Utah at that time. One of my other volunteers, he's a recent graduate of school from Massachusetts, but he's trying to get into graduate school right now. Marcello Toscanini, he's working on trackways. So animals that were swimming through these swamps, but also bigger animals that were walking through these swamps. Turns out we have a lot of turtles swimming in these swamps, lots of really big crocs as well, is basically the short version of his story. And those few images right there are zooming in on some of the turtle tracks. These are turtles that would be swimming through these swamps, maybe even walking along the bottom, leaving behind tracks that get infilled and then fossilized. And we do find lots of turtle body fossils. It's one of my, besides mosasaurs, one of my favorite groups of animals to work on in the fossil record because we just find so many of them. And one of the things we were able to find is this one particular species of soft-shell turtle. We can ID these just based on the texture of the shell because they have unique textures. And this is the northernmost occurrence of this one species. So we're kind of starting to fill in that geographic story across Western North America at that time. Here's another a volunteer who was out in the Netherlands with us, an undergraduate at the time. She's graduated with her master's since then, Margie Cohn. We had a couple days left in that first expedition. She comes over the radio and says, "I've either got a leg bone or a horn." And I said, well, either one is more exciting than what I found because I found nothing that day. It's the story of my life. My volunteers find the cool dead stuff. So hike over to where she's digging, and sure enough, it is a horn. We get it out of the ground, get it back to the lab, and it turns out it's a member of this group of dinosaurs called the ceratopsians. Who's heard of Triceratops? Okay, just about everybody in this room's heard of Triceratops. Triceratops is one of tens of species of ceratopsians. So horned dinosaurs were very diverse. We have lots and lots of different species of horned dinosaurs. The one up on the screen is called Agujaceratops, lived about 10 million years before Triceratops. But what's really neat, so all these different horned dinosaurs have different shapes and sizes of their horns. And this one in particular, though, the horns curve up or out and up from the orbit, from the eye socket. So that round circle right there is where the eye socket would be on the side of the skull of this dinosaur. The horns curve out and up, kind of like a bison or a cow. What's really neat is that no named species of horned dinosaur does that. So Margie, this was her first dinosaur fossil that she ever discovered. Not only was it her first dinosaur fossil, it's probably a brand new species. Found right there in the Book Cliffs outside of Green River. So really cool stuff. Again, all these discoveries being made by the Prehistoric Museum right here locally. Or locally to us, anyway, 3 hours away. So the last thing I want to talk about, the last critter, is one of the more famous ones, and one of the number one reasons why I think our new hockey team should be the mammoth. And this is called the Huntington mammoth. Huntington is a town in central Utah, about half an hour south of Price. And back in 1988, they were working on a reservoir up the canyon from the town of Huntington. And the guy who was running the bulldozer, who was repairing the dam there, hit something, backed the bulldozer out and said, well, that's not the normal mud that I've been going through. It turns out it was this mammoth. So it was discovered on August 8th, 1988. just across the line from Emery County into San Pete County. By number of bones, it's about 50% complete. But the parts of the animal that we have are all the big bones, the skull and the leg bones and the backbone. So by volume, it's about 90% complete. It's only missing the small stuff. And at the time, this was the highest elevation Columbian mammoth ever found. It was found at 9,000 feet in elevation. Previously, folks thought that this species of mammoth were living in the lowlands, in the sagebrush and the grasslands, and feeding on grass. But this thing was found at 9,000 feet. And the Ice Age, this animal was living 13,000 years ago. The mountain hasn't risen that much in 13,000 years. And so it turns out that this animal was living at 9,000 feet. Something brand new was learned about the biology of these animals thanks to the Huntington mammoth. So that's what the site looked like when they were working on this dam in 1988. And after the bulldozer operator found the mammoth, a lot of folks, a lot of volunteers, a lot of folks interested in both paleontology and archaeology descended on this site to help out. There's folks standing around, actually including our first director, Don Burge, looking at the mammoth skull. There's the mammoth skull. There's a big chunk missing out of it in the upper right. That's what we call the discovery mark in the business. If there's a fossil there and you don't know it's there and you hit it, that's what happened. But the bulldozer operator really, was skilled because he recognized, wow, this is not mud. I should stop. And then they found this fairly complete mammoth right there at this site. So it was very high elevation. That's one part of the story. It was very complete. It's young. It's based on our most recent age dates. It's about 13,000 years old. Not even really fossilized. You can go and pick up one of these bones, and it feels like a modern bone with a very low density. It's not super mineralized like that dinosaur bone is, the real one in our museum. So some scientists, I think in 2011, should say on that paper, 2011, came in and sampled the fossil, the mammoth, for DNA. And sure enough, they were able to pull DNA out of these bones. So this was the first Columbian mammoth on the planet to have its genome sequenced. So we learned a lot about the genetics of Columbian mammoths thanks to this. One of the big things, they found out that Columbian mammoths were able to interbreed with woolly mammoths. These two species separated at least 1 million years ago, if not further back in time. But there was very clear evidence of woolly mammoth DNA in this individual. So somewhere along the maternal line, because they were looking at what's called mitochondrial DNA, on that maternal line, maybe its great-great-great-great-great-great-grandmother was a woolly mammoth. So that's a pretty big deal, something that we learned from that project. And the research continues. So I've currently got an undergraduate, Sean Briner, just presented his research at the Capitol yesterday. He's a pre-med major at USU Eastern. He came to me a few years ago and said, hey, I want to do research. I want to get into med school. And I said, well, what do you want to do with your life? And he said, I want to go into geriatrics. And I said, that's great, because our mammoth is really old and has a ton of arthritis. So Sean has been spending the last couple of years diagnosing what sort of bone disease, what sort of arthritis this mammoth is being afflicted with. Turns out, brand new type of arthritis that we see in other animals but have never seen in Columbian mammoths before. So again, cool new discoveries by undergraduates at USU. We're fitting our theme, Year of Undergraduate Research. And so our field program, as well as the in-lab, in-collections research program, is a great way to get involved in paleontology. A lot of folks don't realize, I feel like, that Utah is such a special place. I would argue one of the best places on the planet to study the history of life. And anyone in here can get involved with that as a student or just as a member of the public, as long as you're 18 years of age and older and don't mind camping and hiking and being out in the wilderness, and you care about finding cool dead stuff, then you can come volunteer with our field crew and still have a day job that pays better than a paleontologist. Kidding. So these are some of our volunteers and other folks that have joined us in the field over the years. We work with Science Moab to get high schoolers into the field as well. So we have a lot of ways to get folks involved in our programs. So thank you so much for your time. Thanks for showing up to my presentation. I appreciate it. Yeah, go for it.
My husband told me you can tell the difference between a dinosaur bone and like a rock if you lick the dinosaur bone and your tongue sticks to it. Is that true?
Yeah, so the question there, this is a really great question. And I did an outreach event in an elementary school this morning, and one of the kids, I'm pretty sure it was just because it was a little boy and little boys ask questions like this, because I did. Have you ever licked a dinosaur bone? And I said, yeah, and here's why. So bone is a porous thing. So if you pick up a cow bone or a deer bone in the woods or in a field, especially if it's weathered out, you'll see a lot of porosity where all the blood vessels are flowing through the bone in life. So even though dinosaur bones get fossilized, a lot of that empty space gets filled in. It retains a little bit of that porosity most of the time. So, and if you lick something porous, it's gonna basically suck up your saliva and it'll stick to your tongue. So oftentimes we work in places where the rock and the bone are hard to tell apart. So if I see something and I'm not totally sure, yeah, I'll stick it to my tongue. And if it doesn't stick to your tongue, you just licked a rock. Any other questions? Yeah. Question was, what was going on at Cleveland Lloyd Dinosaur Quarry that you get what I think minimum number of individuals of 48 Allosaurus in one spot? The short answer is we don't know. The long answer is there are four or five ideas about hypotheses of how you get this. One, it was a family group that was killed during a big flood or some other natural disaster. Second is that you had a drought where you kind of like you get in the dry season in Africa. You have the last watering hole. A few prey animals come in. The predators, you've got animals, dying of thirst. The predators come in, start eating those animals, and then they also die, so you concentrate a lot of predators. Could be that something almost like the La Brea tar pits without the tar. So a predator trap where you get animals getting stuck in the mud, where it's a really wet environment, where you have a big sauropod stuck in the mud. All the allosaurs come in to eat it. They get stuck in the mud, that sort of scenario. And then another scenario is something like poisoning. That one's hard to test because there's not always evidence on the bones of poisoning, but the idea would be something like a toxin like botulism that gets into a water body. The animals drink it and they all die. You actually see these mass deaths of birds from botulism stuff like that. The latest research on this site, there's one research group that's still working on it out of Wisconsin. And they're seeing evidence for algae. So they've got algae fossils in the body of water that these animals were preserved in. Now rocks. It's not wet anymore. But it's a lake-type deposit. And there's very clear evidence of a particular type of algae fossil. So that's telling us that there might have been an algae bloom. There may have been some sort of toxins involved, but also there's evidence in this rock formation as well of wet and dry periods. So could be a combination of things. I think it's kind of still an open question though. Yeah.
I was thinking about your ceratops.
Yeah. Yeah.
Do dinosaurs have a cap on their bones? On their horns?
Oh, so like the keratin horn? Yeah, absolutely.
Really?
Yeah.
Those could be like curly horns together.
So yeah, and usually when they get reconstructed, there's I know I told you you could turn it off, but I said this is easier to talk about if I've got it on the screen. Yeah, in our life when we work with artists to do life reconstructions of these animals, we try to tend to be a little bit more on the conservative side because even in the antelope with the really crazy horns, there's usually some kind of indication that they're curling in a certain direction. There might be quite a bit more added to it, especially in some of the elaborate ones. But like if we're doing a life reconstruction of this, we're gonna kind of keep it more on the conservative side. But yeah, there are some instances where you get soft tissue being preserved in dinosaurs. Not really great evidence for what the extent of the horns looked like in these animals. So yeah, I mean, could it have done a bunch of dipsy doodle stuff up there? Maybe, but yeah, just the fact that it's kind of shaped like that shows that it's unique, that it's something that hasn't been named before. But yeah, there would have been keratin on top of this too. So it would have been even, one thing that we can say for sure, it would have been longer and sharper than what the bone shows. Yeah. Yes? Frog fossils or meteorites, so two different things. I've never found a meteorite. Lots of people have. Even more people claim they have. It's one of the most common things that folks will bring into a geology department and say, did I find a meteorite? No, it's a meteor wrong. But I've never actually found one myself. Frog fossils are super, super rare. I've never found any, but there are dinosaur-aged frogs from Nevada, and those are Cretaceous, and there are some that are even older than that down in Arizona. I think those haven't officially been published yet, so I won't tell you more about that. Maybe those have. I don't know. So yeah, there are frog fossils, but usually anytime that you have something that's small with really delicate bones like that, they don't fossilize as much as something that's basically has giant logs for limbs. So easier for this to fossilize than a frog. Yes?
When reconstructing fossils, how often do you rely on at least similar fossils being in articulation to figure out which bone goes where, and how often do you rely on just how the bone is to know what species it goes with and how it goes together?
Yeah, so the question is, how often are we relying on, more complete animals in general? So all the time is the short answer. So more often than not, we're finding incomplete stuff like this. Complete animals in the fossil record are very, very rare. So we are using a lot of what's called comparative anatomy. So looking at similarities between different skeletons of closely related and even distantly related animals. So yeah, we're really lucky that we have a lot of very complete Triceratops, for example, where you can look at different parts of the skull of a Triceratops and be able to say, okay, I know this curve right here should be where the eye socket is, and it should curve, kind of loosely, so I could say that this is the top of the eye socket, and that gives me a lot of information about this particular horn, for example. So yeah, because the fossil record is incomplete, and most animals that we find are incomplete, we do a lot of comparisons with other more complete animals that are closely related. So even though I work at a really great museum with a lot of awesome fossils, you have to go around to other museums to look at other people's fossils to be able to compare with yours. One, to see if you have a hunch that something might be unique. Is it new? And two, how does it fit within the broader, already known tree of life, especially within one given group. So yeah, we look at more complete fossils are almost like mini Rosetta Stones for our less complete fossils. And, helps us say more about less. That was a really good question. Yeah. How big is the biggest T-Rex? Oh, good question. I think They actually just found. I saw something on the news the other day when I was driving up here. They found a really one that's even bigger than the biggest ones. I think the biggest one is probably around 39, 40 feet long, something like that. They've got a couple of big ones. One challenge, one thing it's hard goes back to his question about the complete fossils. We've got fairly complete Tyrannosaurus rex fossils, in part just because people are obsessed with that one dinosaur for some reason. I get it. It's big, gnarly. It's got big teeth. But even when you have a complete dinosaur skeleton, you might be missing chunks of it here and there if it's close to complete, because very rarely do we find it totally complete. And then some parts, one thing to think about too, we're finding the bones. We're finding the skeleton. There's a lot of flesh on that animal. There's a lot of soft bits that rot away after the animal dies. And so what are we missing? In our own skeleton, as you get older, you may slip a disc. You may have problems with the cartilage in between your vertebrae in your spine. That adds space. That adds to my height. If for something as long as a T-Rex, that could, depending on how wide those discs are, that could add feet or subtract feet from the what we think the length is. So there are always going to be estimates for how long an animal is, how heavy an animal is. You got to take those with a grain of salt. But the number I gave you, close to 40 feet-ish, is kind of the estimate for how big they got. At least until this most recent. I think the bone they found a femur, a thigh bone that's bigger than any other T-Rex thigh bone. So it's probably bigger than 40 feet, potentially. Any other questions? Yeah.
You mentioned using LiDAR scanner on your phone to help map out.
Yeah.
What other technology and tools do you use to help categorize and map and define fossils at a dig site?
So the old school method is with that middle photo there, using a meter by meter grid, a plumb bob, and then somebody standing over it with a map, literally just sketching it out. We still do that. We do paper maps, mapping out the bones in the quarry. LiDAR, things like that, and other methods of 3D scanning, it's pretty new. A lot of the really good 3D scanners are, pushing, they're thousands, sometimes up to $10,000. That's not something that I would want to take to a very dusty place. In some places that we work, the dustiest places that I've ever been. So something like, my iPhone, if you've got an iPhone with the three little camera thingies there, they might have fewer than that now and still have LiDAR in the new ones. Mine's all scratched up because I live in the dirt. That was something that we just kind of tried out that one year, and it turns out it does work, works pretty well. And I think there has been more movement towards 3D scanning as a way to document your field sites. On top of the traditional paper mapping, we do photographs. We try to photograph just about everything before it comes out of the field, and then of course after it gets prepped as well. There's for larger track sites, there's another, or even smaller things as well. There's a method called photogrammetry. Using those photos, if you have let's say we've got a fossil, we're going to lay our fossil down and pretend it's still in the ground. But we can do this after it's been prepped out as well. If you take a bunch of photos from a lot of different angles around a fossil, and there are apps that do this for you now on your phone. The traditional ways to use like a DSLR camera and take a lot of photos from different angles, maybe low angles, high angles, go all the way around the fossil. You can actually there's software that will generate a 3D model based on all those photos by stitching them together. So you can do that for a bone. You could do it for a map area. So that's something that folks have been using. People have started using drones to map out larger areas as well, using LiDAR photogrammetry just from up in a drone. So especially there are some examples of really long trackways, dinosaur trackways. That's a good way to kind of get a top-down view of what the whole trackway looks like. So, just about any time. That's one of the cool things. And, it's not just, digging up, mapping fossils. Digging up fossils really hasn't changed that much. But it's the data along with those fossils, our work with that really has changed. So a 3D scan of a fossil is great. So for a lot of reasons. Number one, there's only so much you can do with a photo. We can describe what a fossil looks like. We're using our human words in whatever language we choose to describe something. But having, if you can't actually hold the fossil in your hand, let's say I have a colleague in Spain, because Spain, they have a lot of sauropods closely related to this. If I have somebody in Spain that wants to compare their sauropods to mine, then I can send them a digital file of that. I can send them that 3D surface scan to be able to look at it, spin it around in a digital environment, right next to their fossil. And once you have a 3D scan, you could also, if you put it in the right file type, you can then print it. So a little bit harder with big bones, but you can, with the digital age that we're in now, if you have these digital data, and I'm going to do this with this baby ankylosaur jaw, you can turn that shape file into something that you can send to a 3D printer, and then you have a copy of it. You can send that file anywhere on the planet. They can print it out. So it's really being able to share these resources with anyone on the planet without having to mail the actual fossil and potentially damage it. So, and then there's a lot of other things that you can do, not to get into the weeds of research, but looking at mathematical shape changes in different bones and everything. So lots of stuff that you can do in a digital environment when you have those 3D scans. Yeah. Oh, another question. Lots of bugs around when the dinosaurs were around. It's funny because that was one of the premises for Jurassic Park. They were finding these mosquitoes in amber, and the mosquitoes suck the blood out of dinosaurs, so they get dinosaur DNA out of the mosquitoes. That would never happen because DNA doesn't survive for millions of years. So we find a lot of what we know about bugs during the Age of Dinosaurs actually does come from amber. There are some instances where you get bugs being preserved in really fine-grained mud and sometimes volcanic ash. We learn a lot about the bugs, including not just their hard parts, but sometimes even their soft parts from fossilized tree sap, basically. So lots of bugs. Some of the same groups of bugs that we have around today. There were dung beetles living during the Age of Dinosaurs, eating dinosaur poop. There were mosquitoes, for sure. You started getting a lot of the pollinator insects. You see a lot of them starting to show up when flowers start showing up kind of towards the end of the Age of Dinosaurs. So, a lot of different parts of our ecosystem today would have been very similar back in the Mesozoic during the Age of Dinosaurs. The big animals, of course, were different. We had ceratopsians instead of deer and moose. We had tyrannosaurs instead of wolves and bears. But there were turtles. There were lizards. There were snakes. There were pine trees. There were palm trees. There were, little bitty mouse-like rodents even, or mouse-like mammals. They weren't true rodents yet, but there were birds kind of towards the end of the Age of Dinosaurs. So a lot of things would look the same, just the big animals were quite different, and in most cases the climate was much warmer. So we can still look to the past. That's one of our big things. We think about interpreting the past based on what we see around us in the present, but we can use a lot of that history in the past to tell us about our present and potentially the future too. Oh, one more. Oh, it'll pull off. Yeah, so it sticks to your tongue just a little bit. You can. It doesn't rip off. It doesn't hurt too bad. Some of them, if they're really porous, they might hurt a little bit more than others. But yeah, they come off easy. Just don't lick a frozen light pole. Yeah. I haven't seen them yet. No, they're the geology departments. So.
There's people up there who could talk to you about those if you wanted, and Josh could probably go up there and give them.
Yeah. I could probably talk to you about them, but I think you should make the students talk to you about them too. But yeah, no, I'm happy to go up there and see what they got. I have no idea what they brought. But if you come to Rock and Fossil Day tomorrow, I'll have this. If you didn't get a chance to take a selfie with it and you're interested in doing that, go for it. But tomorrow, tell your friends. You'll be able to help us find shark teeth, fossil shark teeth under the microscope. I'll have a couple of dinosaur bones, and it'll be a good time. You guys are going to have a ton of stuff in geology, so.